So just by way of introduction, my name's Taylor McCurdich. I'm the industry manager for mining, and I also wear a secondary hat for oil and gas here in Australia. So I've been with the company around 3 years, and before I was with BHP for about 5 years in a number of improvement and processing optimization roles. And I'm going to be speaking to you around unlocking mineral processing value with different applications of online sensors. So for those that aren't familiar with Endress & Hauser, I'm going to give you a very brief introduction about what the company does, and then I'll delve a bit deeper into some items around getting some additional insights via big data, and then also around how to optimize some sub-processes with additional instrumentation. So very generally, our product offering involves a complete MIV approach. So what that means is we provide instrumentation across a very wide range of applications in the mining industry. So whether it's level measurement, flow, pressure, analytical, so that could be liquid analysis like pH, or it could be gas analysis, temperature measurement. And then we also provide some system products and data managers so that you can utilize the information that the instrumentation develops and generates in order to bring value for your operation. And then we also have some software solutions that can enable us to get some additional insights to that data. In terms of service offerings, so we can provide on-site or remote support as well. So the remote support component is becoming increasingly popular with the current digitalization acceleration that we're experiencing. And we also can provide services for the entire life cycle. So we work with a wide range of EPCs from like pre-feed stage all the way up to like optimization projects with consultants, and then of course the end user as well. And then we can also assist and develop strategies to optimize their maintenance processes. So I won't go too much into that in this presentation. I'll try and focus around the processing side. We can also provide solutions. So we have engineering team here in Australia and across the world as well, since we're a global company. But we have solutions around transfer, storage and distribution, quality compliance, particularly for like food and beverage industries or life sciences, and then solutions around life cycle asset management, again, bringing back to improving the maintenance of the plant. A very brief overview of some of our product innovations. So from the 50s and the 60s, where we were experts in level limit switch detection using vibronic fork, all the way to the early 2000s, where we started to have a lot of world firsts and innovations around MemoSense technology, which is inductive coupling for analytical devices. We've launched the first field device with Ethernet IP back in 2010. In 2012, we had some gas analytic portfolio acquisitions. 2014, we released self-diagnostic technology, which is now available across our entire portfolio. 2017, the first self-calibrating thermometer in the world. And 2020, the first battery-powered IoT 80 gigahertz level device. And over the last few years as well, we've been focusing on acquiring a number of different technologies from different companies, because we are working along the strategy of bringing lab and process insights into heavy industry. So from gas analytics to moisture and bulk solids, they're the type of companies that we acquired over the years. Now that's a bit of an introduction about Endress & Hauser. I'll delve a bit deeper into where we can get value in terms of data insights. So I think a lot of you would have heard around the term of industrial IoT. I would believe it's quite prevalent now in definitely everyday life. There's probably some component of IoT that you interact with, from parking meters all the way to industrial IoT applications. But we know now that this has developed a lot of new data. The good thing about this new data is it can generate new information about some of the processes that we might not be aware of. And this additional information then will allow for better decisions, both on the operational or the plant side, or also throughout the engineering side. And these better decisions will then further lead to improved optimization, and then finally success of the end goal, whether the processing plant requires a low cost base or a low processing cost, or maximizing yield, and again probably yielding back to delivering the shareholder value that a lot of operations hold key. In terms of field instrumentation, so in probably along the lines of the last 20 years, we've really seen the acceleration of adopting digital instrumentation. So analog instruments are really, I guess, outdated information. They only have a single process variable. But the fact is that a lot of processing plants now these days, brownfield projects, even have instrumentation that is already digital. But unfortunately, they're only using the primary variable still from this digital instrumentation. And this is where the additional value can be unlocked from big data. So asset data is really still hidden. The plant asset information is not analyzed or captured. And we find that on average, only about 3% of all the device data is used from field instrumentation. And why only 3%? Well, I'll delve into that over the next few slides. But some of the reasons for that is that there's not very seamless integration between field instrumentation and bringing that to like a system where you can bring value. And at the moment, there's still a high engineering effort and a lot of expertise required in order to analyze the data and the information that comes through. An example IoT ecosystem that could capture this data in order for you to develop and optimize your process would look like this. So you've got the field instrumentation down the bottom. There might be some devices that are wireless. There might be some with integrated gateways and that are already fully IoT devices. This can go into a cloud solution. So whether it's like a third-party cloud, or whether it's an instrumentation cloud or a control system. And then from there, you can get applications, individual applications that can help operators in the field to optimize their process, or whether it can go into a third-party big data analytical platform in order to capture all that information and optimize your process. And you can see as you move further up into the IoT network here, you start to add additional value. So rather than going from different primary and secondary variables, you can actually get that information, gather it, compare it to other different components as well, and then you'll be able to optimize your process even further. So what we've seen is the convergence of OT and IT. So we work with a number of partners. Here is just one example, SAP. So they're the experts in business processes. As we know, they're a very big name. And then while we consider ourselves the experts in the process industry side, and we're helping to integrate our ecosystem with IT ecosystem. And then that's where you start to bring the value with a process. In terms of open integration, so we have a partner program because we do see the value in being able to optimize your process using the IT and integrating and converging that OT, which we see in Industry 4.0 now. And we make sure that we use open standards for digital communication. So we eliminate one of those barriers of the high engineering effort required to get the secondary variables of the field instrumentation back to a data analytics platform that can start to bring value. We would be like a bit of a middleman, I guess, or a broker for that asset information that goes from our field instrumentation to like an IoT cloud, for example, that we can also get additional information from multiple vendors and then deliver it as a two-way street to our multiple users that we have in some of our pilot programs, as an example here. I mentioned very briefly around asset management. So the thing is, and I'll go into the segue shortly, but asset management information from field devices is the way to get the how the process is running as well. So just from an availability point of view, we know that unplanned maintenance is mainly now these days preventable. In terms of even instrumentation level, there's a lot of diagnostic information that's available in our field instrumentation, as I mentioned before, but it's not being properly used. So this is where the asset health monitoring systems can come into it. Yeah, you can take action on that diagnostic data, and then the outcome is to support preventative maintenance initiatives on site. The device diagnostics that can come from devices, such as this one here, which is a Coriolis flow meter. As you can see here, initially all the secondary information was around the preventative maintenance side of things. So what's happening with the temperature inside the device, what's happening with the resistance, the power supply, the CPU. And then over a period of time, the diagnostics of the device have expanded to encompass maybe something that's happening on the process side. So now these days we can use diagnostics in a Coriolis flow meter, for example, to determine if there's corrosion in the meter, if there's a coating in the meter. Maybe from a process side there shouldn't be coating in that pipe or in the meter, so that can enable you to optimize it. It can detect if there's air bubbles or cavitation, and that might be a line that was not designed to have any entrained air, or maybe there shouldn't be in the process. And now we're starting to get the information from where it came from, the asset health management, into some useful information for process optimization methods. For level, so this is just another example. This is a radar device. Again, the diagnostic technology in the sensor is checking temperature, supply voltage, whether the cable inside is broken, maybe the RAM is broken. So just for the level device, there's more than 80 diagnostic measures that are permanently running, and you can actually capture that information and bring it to do something like this. So in this case, our radar device here, our levels, continuous free space level sensor, by utilizing and analyzing the signal that returns back to the device, you can determine if there's buildup on the antenna, as an example. Maybe there shouldn't have been buildup on that antenna in the process. Another one that we can also detect now is foam. So whether there's foam in the sample or the tank, and you can utilize the instrument to send either a switch output when there's a critical level of foam, or you can trend that on a continuous level, as you can see on the right hand side. And that will be able to get you additional process insights from what was just a level sensor to now you can determine foam, you can determine buildup, and maybe the process temperature as well. So you can start to see that you're getting additional insights into what the process is going without actually getting a sensor for that. I'll go into some of the sub-process examples now. So in terms of what we see when our end user was to come to us and say, well, we're working on a thickener optimization project, but the instrumentation that is on there may be insufficient in order for us to optimize the entire sub-process. That's where we can come in and we can say, well, if you wanted additional information on what's coming into the thickener, maybe we can help you with the flow meter, with total suspended solids as an indication of how much mass is coming into there. And often end users want to optimize processes, and in order to do that, they need a water balance, maybe a mass balance, and maybe some quality information. So maybe they want to determine the quality of the flock or the coag that's being added, and they want to implement some type of feed forward or cascade control in order to further optimize the running of the thickener. So that's something that we work with the end users, and we can also help recommend with. And some of the benefits of using the correct instrumentation in order to achieve the end user's optimization project is we've helped reduce power consumption by reducing the amount of recycled water that might go to a return dam, improving underflow percent solids to maximize beaching angles and enhance tailing storage capacity, which is a large cost benefit for the end user, and optimizing or actually even recording the